Look at the equation on the screen. You already know it. But today, you stop seeing it as math. You see it as a decision. 2 terms. 2 locations. 2 completely different treatments. Now look at the number. 51% of total pressure drop inside a 3-foot zone. 3 feet. Out of thousands. That is where your well is being choked. Now look at the last box. Wrong treatment. This is the real risk. You pump acid on a reservoir problem. Nothing changes. You fracture a near-wellbore problem. You overspend massively. Same well. Same symptom. Completely different solution. This lesson is about one question. Where is the damage? Get that right. Everything works. Get it wrong. Nothing works. Look at the geometry. As fluid moves toward the well, the flow area shrinks. Everything is forced into a small space. That creates a steep pressure gradient near the wellbore. 1 foot from the well, pressure drop is extreme. 100 feet out, almost flat. That is the physics. So small damage near the wellbore has massive impact. Large damage far away has much less effect. Near wellbore damage sits exactly where flow is most sensitive. Reservoir damage sits where the system is more forgiving. This is why location matters more than volume. A few feet can control the entire well. Hold this comparison clearly. Near wellbore damage is small, but it dominates flow. Reservoir damage is large, but its effect is diluted. Now look at what matters in the field. Near wellbore damage is accessible. You can treat it directly. Reservoir damage is not. You cannot reach it with standard tools. That means 2 very different realities. Near wellbore fast, targeted, high return. Reservoir large scale, expensive, uncertain. So here is the rule. Most of your value sits in the near wellbore. That is where you focus first. Now connect this to the equation. Skin sits directly in the denominator. That means its impact is immediate and strong. Take a typical case. Base value is around 9. Add skin of 9. You double the denominator. Production drops by half. All from a few feet of damage. Now compare reservoir damage. Even a wide permeability reduction across the reservoir only slightly changes the logarithmic term. The equation compresses that effect. So near wellbore damage hits hard. Reservoir damage spreads out. That is why removing skin gives fast gains. And reservoir treatments give slower returns. Now apply it. 2 wells. Same symptom. Declining production. Case 1. High skin. Normal pressure. The reservoir has energy. But flow is blocked near the wellbore. That is a local problem. You treat it with acid. Case 2. Low skin. Declining pressure support. The near wellbore is clean. The reservoir cannot deliver. That is not an acid problem. That is a reservoir problem. You need injection or fracturing. Now lock this in. Same symptom. Opposite diagnosis. Opposite treatment. This is where engineers fail. They skip the diagnosis and just react. Don't. Run the test. Read the data. This is your decision gate. 2 data points are enough. Skin and reservoir pressure. High skin plus normal pressure near wellbore problem. Use cleanout or matrix acid. Low skin plus declining support reservoir problem. Use fracture or injection. That is it. The mistake is not technical. The mistake is skipping this step. No diagnosis, wrong treatment. Wrong treatment, wasted cost and no improvement. You don't need complexity. You need discipline. Now connect this to your tools. Near wellbore problem matrix acidizing. You remove the restriction directly. Reservoir problem hydraulic fracturing. You bypass the damaged rock. These are not interchangeable. Acid works within feet. Fractures work over hundreds of feet. Both change the flow system, but in different ways. So this lesson is not classification. It is selection. Pick the wrong tool, and nothing changes. Look at the pressure profiles. Near wellbore damage shows as a sharp drop near the well. That spike is the restriction. Remove it, and flow recovers immediately. Reservoir damage shows as a smooth decline. No single point to fix. That difference tells you everything. One is a choke. One is a distributed resistance. And only one can be fixed locally. Train yourself to see this pattern. Everything in this lesson comes down to location. Near-Wellbore region controls flow, not the full reservoir. Small damage can cut production in half. That is leverage. Skin is driven mostly by near-wellbore effects. That is where your return is. Reservoir damage exists, but it is harder and more expensive to fix. So your entire job is this. Find where the problem sits. High skin with good pressure, treat locally. Low skin with poor support, go reservoir scale. Get the location right, and the treatment works. Miss it, and nothing you do will fix the well. Use this slide as your mental checklist. Radial flow is logarithmic. The near-wellbore controls inflow. That is the physical reality behind everything you do. Near-wellbore damage is small, but it dominates production. That is where most of your value sits. Reservoir damage is larger, but harder and more expensive to fix. Now lock the diagnostic rule. High skin with normal pressure, treat near-wellbore. Low skin with declining support, go reservoir scale. 2 numbers. 1 decision. Get it right, and you pick the correct treatment. Get it wrong, and nothing works. That is the whole lesson.